Hello, everyone. This is the next RapidMiner implementation, and we want to see how combining different models like boosting or bagging methods can help us to improve our accuracy in data mining models. So again, we will use the universal bank dataset for this example, and we can drag and drop the data set, and preprocessing is the same. We deselect the zip code and set the role of personal loan as our objective, and the objective is to whether an individual accept the personal loan offer or not. And we have other operators that explained before. And then we use the split data. And here we don't have any test data. We just split data to send into the this compare ROC operator. So the goal of this compare ROC operator is to see the performance of different models based on their ROC. And here we have different methods. I will explain this later. Let's run the model because it takes time. Then I will, in the meanwhile, I will explain these one by one. So while the model is running, I will explain one by one. The bagging method is when we randomly sample 10 times and randomly select 70% of the data as sample and then build a weak model. So in this example, we will build the naive bias as the base model and then bag them and predict the output. In boosting, we first build the weak model, then based on the misclassification of the first model, the second model will be focused more on the misclassified instance. And finally, after 10 iteration, oh, it's done. So let's explain this first, and then we will talk about the result. And in the boosting, finally, the 10th model is the most accurate model because it focuses more on our misclassification in the previous stages. And stacking is the combination of three, like n different base model, which is it can be some basic machine learning models, and then we have a super or stacking learner model. In this example, it is the naive bias, and it just combines the output as the output of previous stage. So stacking is a machine learning model which builds on weak machine learning models in the previous stage. And we have a simple voting method, which just uses the majority role of different, these three basic learners. And we have random forest. So random forest is a well-known machine learning models. It uses, in this example, it uses 50 decision tree, simple decision tree, and then combines their decision to make the final decision. We have gradient boosting as another powerful boosting method. And we have KNN, naive bias, and decision tree as other weak models. So in this example, we manually created the bagging and boosting, and then we also used already implemented machine learning models based on bagging and boosting, like random forest and gradient boost. So we want to see how is the performance of this different implementation. So look at the result, and this tab is the main tab that you will report your output in the assignment. So as you can see, the green one or random forest has the best performance based on the ROC, since we always look at the upper left corner when we analyzing the ROC model, and other machine learning models also uh, uh, have like acceptable performance, and the worst performing model seems to be KNN. And yes, so you can compare these different models. And in your assignment, the second question that you will answer is eBay auction dataset, and you will do some pre-processing, and then your objective function of y is competitive, and it's a binary classification. And you will use the example that I just explained to run different models, and then report the ROC curves for 9 models, and so answer that which one of these models is best performing, and briefly explain that what is the general process of bagging, boosting, stacking, and voting in the process that you ran. So uh, you will use this example to answer the second question in the assignment. Thank you.